This problem describes a solid of revolution created by rotating the given region about the x-axis, and we are asked to find the volume of this solid. We begin with a sketch of the region in 2D. We need a y-axis and an x-axis. Y equals to x to the power 4 looks like a squashed parabola, and it goes through the origin and also through the point 1, 1. So the curve looks something like this. Let's make sure we also label this on our graph. Y equals to the fourth root of x also goes through the origin and the point 1, 1, but the curve is that of a root function and looks something like this. And we also label it. Now that we have sketched both curves, we shade the enclosed region and indicate the axis of rotation, which in our case is the x-axis. We will also draw one general washer that will help us set up the integral to calculate the volume of the generated solid. Since we have to rotate around the x-axis, we draw a line through the region perpendicular to the x-axis, and that then allows us to finish it off as a washer. And I shade it in with stripes so we can see it. It will also help us to indicate where our radii are for the large disk and the small disk. So right here, all the ways down to here, is our large radius, and right here, down to the x-axis, is our small radius. Now we can express the volume. So V is equal to, in general, the integral from A to B of the washer's area integrated with respect to the appropriate variable. In our case, the washers cut through the x-axis. That means that dt is actually dx. And our washers run over the interval from 0 to 1. That means our integration bounds run from 0 to 1. And the area of the washer is calculated by taking the area of the large disk minus the area of the small disk. And since we already have some nice names, the large disk is the area of pi capital R squared, and the small disk is the area of pi lowercase r squared. Now we have all the information to set up our integral and calculate the volume. So the integral from 0 to 1 of capital R squared, which is the fourth root function of x, all squared, minus pi lowercase r all squared, which is our x to the power of 4 function, all squared, dx. And now we simplify this integral, take out the pi since it's a common factor, and we get x to the power of 1 over 2 minus x to the power of 8 in the integrand. And we can readily find the antiderivative of both of these terms, and so we get pi times x to the power of 3 over 2, all multiplied by 2/3, minus x to the power of 9, all divided out by 9, And then this needs to be evaluated from 0 to 1. We notice that the lower bound of 0 will create a value of 0 since both of our terms have x as a factor in it. And so we're just left with pi times 2/3 minus 1/9. And once we simplify this, we get that our volume is 5 pi over 9 cubic units.